Okay, well, hello everyone. This is the quiz review for 7A, not 6A. That is incorrect on the stream. That's annoying. And the let's talk about the quiz. Hey, that works still. Okay, so these first ones, this is stuff from pre-calc. So remember there are these rules, right? I've got these rules. I've got if I take e to the a let's see. If I take e to the ak, if I take e to the a times e to the b, remember that equals e to the a plus b. So when I do the log of this whole thing, right, this is going to wind up being the log of a times b. It better equal the log of a plus the log of b. So, and remember there are these other rules, right? I've got that the log of a over b equals the log of a minus the log of b. And then I have that the log of a to the k equals k times the log of a. So, do we remember these rules here from pre-calc? These are these log rules, and you need to have them because in order to do any of the logarithmic differentiation stuff, you need those rules. So what we have here, this is kind of just a throwback here. If I have the log of a to the 10, that's the same as 10 times the log of a being 5. I get that information here. And the log of b was 2. So I wind up with 10 log a of 5. And then again, with this log of a times b equaling the log of a plus the log of b, I wind up with 7. This one, I miswrote it this morning because I thought that was a 2 when I was reading it first time. It's an x. So this becomes x times log of b, which equals just 2x. And this one's 5 minus 2, right? Log of a minus log of b, which is just 3. So how do we feel about those 1 to 5? Let's see. I've got a, let's see, multiple choice. 1, 2, 3, 4, 5. So how do we feel about that 1 to 5? And if you don't, remember those, that pre-calc throwback on WebAssign. So if you go over to WebAssign, if you're uncomfortable with some of these, I encourage you to go to WebAssign and do that the pre-calc review logarithmic exponential thing. It's got a bunch of those on there. A bunch of things that you kind of need to recall, and then I even put some of them in the and then there's some of them are going to be in the regular WebAssign. So if you didn't do that extra credit and you don't feel comfortable with this stuff, I encourage you to go hit that extra credit and hit that extra credit and request an extension if you need one. Okay. All right, moving on. This question 2 here is all about so the idea of this question was you go on to Desmos and you print up the you go up onto Desmos and you print up the old graphs of these things like log and e to the x, and they're inverse functions. So you wind up with this idea that I've got e to the x. I've got, as I head to, so for log, as I head to infinity, it goes on and on forever, except it does it very slowly. And then as I go to 0 from the right, it goes down to negative infinity. And then e to the x, if I've got e to the x, as I go off to infinity, it's infinity. But as I go to negative infinity, it's 0. So how do we feel 1 to 5 about that one? So, the idea was to just jump on Desmos and graph it for yourself. Okay. All right. So this one right here, you had to take the derivative of both with respect to times. And if you take the derivative of both implicitly, you wind up with this, the orange solution, the orange thing is not needed. This is the final answer you need. This is the final answer. This right here is not needed. All right. So the idea here is I implicitly both. I've got a product rule here. So this becomes the derivative of the first times the second plus the second plus the first times the derivative of the second. And since I don't know anything about these, I wind up with this relationship between dp and dt and dv, dp dt and dv dt. So how do we feel about, that one's not it. That one's not it. How do we feel then about question 3 there, 1 to 5? Okay. All right. And then one of the things that this does, if I do this implicit differentiation here, the interesting thing is I can relate the change in this variable to the change in that variable. So I can just go ahead and play with it. And I wind up, this is called a differential equation, by the way, first order, if you care what it's called. All right. So here was the idea behind this thing, right? I draw this little sketch here where the tangent line is, and it's got some properties. Now, I didn't need to write this. But, it looks like it's going to have a slope of -1, an intercept of 2, right? So something like y equals -x plus 2 is kind of my guess for what that thing is. All right. Now let's see if our guess is right. So what I'm going to do here is I'm going to take the derivative of both sides. So with respect to x. So the derivative with respect to x, I break it up using the sum rule. And I wind up with this x times y. I'm going to need a product for that. Because the journey of x kind of looks like this. Right? There's an x that goes to an x squared. Then there's this x that comes in here and an x here because of this xy term here at the bottom, right? And this xy term means that I had an x that became that x. But then I had an x that became a y that became that y. And then I have an x that became a y that became a y squared. And then I just kind of have a nothing, right? No change was on the right. So this kind of journey of x thing, right? Here I'm going to have a chain. Here I've got a product. Here I've got just a simple power. So when I do that, I wind up with this term in the middle that requires a product rule. Okay. So I've got the 2x, I've got the d over dx of x, right? The derivative of the first times the second plus the derivative of the second times the first, plus this 2y dy dx. That gets generated because of the chain rule, right? I want to differentiate in terms of x, and I've got a y. And that becomes 2x plus y plus dy over dx plus times x plus 2y dy over dx. Now, if I want to solve for dx, to solve for dy over dx, you do this maneuver here. So if I wanted to, if the question made me solve, this would become 2x plus y equals x times dy over dx with a negative sign in front minus 2y dy over dx. So I wind up with 2x plus y over negative x minus 2y equals dy over dx. So if you want to solve it, that's what it looks like. I don't have to, but what I end up doing is I sub in my x and y, which were both 1, and I wind up with, 3 over negative 3. I wind up with negative 1. So my point slope formula for my y is going to be y minus 1 equals negative 1 times x minus 1. And that's the slope of my line. And then I ask the question, is my answer in part B consistent with what I drew in part A? And I say yes, it has the same slope. It has an intercept matching. Just saying the same slope is enough. And if it turns out they don't match, don't lie, but say they should have. So usually you can get a point or two back by being intelligent and saying, they didn't match, but they should have. So don't lie when that happens. But how do we feel about that one, 1 to 5? The question. By the way, there's been one of these on every test too since, I don't know, probably since Newton and Leibniz gave their first tests. These things always show up, these curves type things, Sometimes there's a, witch's hat. Sometimes there's a crazy, sometimes there's a, I don't think we've ever done an asteroid because those things are a pain. Those things have algebraic, Malox you will need. But the cardioid, is a classic. That one always shows up on tests. Okay. So that's the quiz. Any questions?